All right, folks, it's Bass Action back in action here. In this video, we are going to look at really an overall view of quadratics. So instead of going through some of the nitty-gritty that you would have done back in your Algebra 1 and Algebra 2 days, we're going to kind of take the key values, just our key values, and we're going to look at how we can utilize those to answer some important questions for pre-calculus. So we want to be able to understand the extrema. Remember, that's going to be our max or min, where the graph is increasing or decreasing, and the x-intercepts. Now, the x-intercepts are one of the key values that we're going to use to work on our inequalities. So we're going to use our x-intercepts, and then we also need to find that vertex, because the vertex of a parabola will be the extrema. There will only be one. Okay, and it will be both a local and an absolute. So let's look at our different forms. So I've got 3 different examples on this page. We're going to go through all 3. The first one here is in our good old standard form. And to find the vertex in standard form, I'm going to do this under the rough sketch area because we're going to use it here in a second. We're going to first find the x-coordinate of that vertex, and we're going to do that by doing negative b over 2a. So in this case, that's going to give us a negative 2 over a 2 times 1/2. Well, of course, 2 times a half is just 1, so the x-coordinate of our vertex is a negative 2. Almost forgot to write that negative there. Now, to find the y-coordinate of that vertex and finish off the whole ordered pair, what we're going to do is we're just going to take that negative 2 and substitute it. So I'm going to have a 1/2. I'm going to go ahead and do the math and already call that a 4. I'm going to say minus a 4 because it's going to be a 2 times a negative 2, and then minus a 1. Putting all that together, that's going to get us a negative 3. This is going to allow us to answer this first question right here about the extrema, because the extrema for a parabola is always going to be the vertex. Always, always. There's not going to be an exception for that. So, and since this particular parabola is an upward turning parabola, I know that this is going to be a minimum. So I'm going to, and we'll see it in a rough sketch here in a second. So our minimum is going to be at a negative 3, or sometimes you'll see it written as the whole ordered pair. It really depends on what the directions are asking for. Now, let's go ahead and find our x-intercepts, because that's going to let us finish this off, and I'll come back to our questions here in a moment. When we want to find our x-intercepts here, we're going to go ahead and take a look at our equation. We're going to set that equal to 0. So we're going to say our 1/2 x squared plus our 2x minus 1 equals 0. If we get rid of all of our fractions here and clear them out, we'll end up with a nice x squared plus 4x minus 2 equals 0. Well, now this is beautifully set up for us to be able to complete the square. So we're going to get an x squared plus a 4x plus a blank is going to be a 2 plus a blank. We're going to fill in our blanks here of a 4 and a 4. So we'll get an x plus 2, quantity squared equals 6. And we'll do our square root and our square root. And that's going to get the x-intercepts at, and we would write these if we wanted to write the full intercepts as ordered pairs. So we're going to say a negative 2 plus or minus the square root of 6. Now, with all that in mind, we've got everything that we need to do a rough little sketch of this parabola. We're going to have our vertex at a negative 2, negative 3, so it's going to be down here. We can see that our 2 intercepts, square root of 6 is going to be a little bit more than 4, so I know, or more than a square root of 4, so this will be a little bit more than 2, so I know that I'm going to have a positive and a negative x-intercept. So I'm going to go up like this, and I'm going to go up like this, and it doesn't even have to be pretty. Not even caring about that. That means that this ordered pair and this ordered pair are a negative 2 plus a square root of 6 and a negative 2 minus a square root of 6. Now, based on that, what we can do is we can now identify our increasing and decreasing intervals. We can see that we're decreasing until we get to that vertex. So I can go ahead and write the decreasing interval of negative infinity to the x-coordinate of that vertex of a negative 2. And then I can continue on, and I can write the increasing interval is going to go up this way. So now it's going to increase, and it's going to start its increasing interval at the x coordinate for the vertex, and will continue on to positive infinity. Now, where is this function greater than 0? Well, I can see that it's greater than 0 everywhere that it's above the x-axis. So it's going to be the outsides of this parabola. So it's going to be a negative infinity to a negative 2 minus a square root of 6. And since this is open, this will be open, union, and then a negative 2. Sorry, I didn't mean to have that comma there. Let's get rid of that. There we go. Then our negative 2 plus, it's kind of frozen up here on me. Plus a square root of 6 to our positive infinity. There we go. Okay, now that's probably our longest one. I think the standard form is, but let's go ahead and take a look at our next one. And I think you're going to find this one's going to go a whole lot faster. Now, this one's really easy to rough out a sketch right away for ourselves because this is our nice vertex form. In our vertex form, we can immediately identify the vertex as a 1, negative 6. So if we want, we can rough out this graph and go 1, negative 6, and then I'm going to go ahead and I'm just going to give this a nice upward turning here. I don't actually know if these are positive and negative yet, but I'm going to guess that they probably are. Now that means that our extrema, I'm going to go ahead and label this 1, negative 6. Our extrema, we can see that again we have a minimum, and this time it's going to be at a negative 6. Remembering sometimes the directions might ask you to write that whole ordered pair. Now, we can't tell, or we can tell our increasing and our decreasing. I was going to jump ahead to the inequality. We can do our increasing and decreasing. Again, we can see that it's decreasing from here to here. So it's decreasing from a negative infinity to the x coordinate of the vertex. And then it's going to be increasing from here to positive infinity, so it's going to be increasing from the x coordinate of the vertex to positive infinity. Now let's go ahead and find our x-intercepts, and these are already so beautifully set up for us to find. We're going to say 0 equals 2 times x minus 1 squared minus 6. In the vertex form, it's set up to solve by square roots. So I can move that 6 to the other side, and I'm going to get a 6 and a 2 and an x minus 1 squared. I can divide by 2. That's going to give me 3 and x minus 1 quantity squared. Now I can do the square root of each side. So my x-intercepts are going to happen at a 1 plus or minus the square root of 3. So let's go put those on our graph. So this is going to be a 1 minus the square root of 3, and this will be a 1 plus the square root of 3. Based on that, we can easily answer this inequality. Where is our function less than 0? In other words, where is it below the x-axis? Well, this whole portion here is below the x-axis, so now we're just going to give this interval of numbers for our answer. Notice that this time, since our inequality is inclusive, we're going to use brackets. So we're going to say 1 minus square root of 3, comma 1 plus square root of 3, and now we've beautifully answered that inequality. Like I said, that one's a lot easier for us to do. Now let's go ahead and do our next one. This one, what we're going to notice right away is a downward turning parabola. So this extrema is going to be a max. So what we need to find is our we need to find our vertex for that. What I want to do is I want to rough out this graph for us, recognizing that this one is in intercept form. In intercept form, these two values are going to give us the two intercepts. So that means that I have an intercept at a -1 and I have an intercept at a positive 5. And then mine's downward turning, so I can rough in this graph right away. Okay, now I don't know how high that vertex goes, but that part doesn't really matter. Notice that as soon as we get this graph with these intercepts, you can answer this piece. And I know I'm bouncing around in the order that I'm answering these questions, but I'm doing that pretty intentionally because I want your brain to kind of choose what works best for you in terms of an order of the questions, because the order that we write them isn't necessarily the order that you might want to answer them. So for example, I can do this inequality right away because I can answer this intercept question right here already, okay? Remember, all we did for those intercepts was take the x plus 1 equal to 0 and the x minus 5 equal to 0. So that's how we quickly found those. Now, if we want to know where the graph is greater than 0, this portion here is greater than 0, so our answer is going to be the interval that's causing that. So we're going to say -1 to 5, and I just caught myself there. I was right in that bracket from the past problem, but it's supposed to be a parentheses on this one. So we do want to be careful and get that as a parenthesis, since it is not supposed to be inclusive. Now, we can also do we need to do our increasing and our decreasing, but we need to finish off this vertex. So what we're going to do is we're going to find the midpoint between these two values. You can do it mentally, you can write it down, it's really totally up to you. So if we do a -1 plus a 5 divide by 2, that's going to give us our x coordinate of our vertex, and we're going to find that's a 2, okay? So I know that this right here is a 2, and this is a 2 in this ordered pair. That means that I can look at my increasing interval, and that's going to be then from -infinity to that x coordinate of the vertex. And then I can also do my decreasing interval. That's also then going to go from the x coordinate of the vertex now to a positive infinity. So the last thing that we need to do is figure out what is this actual max value. We need to take this 2 and substitute it back in. So we can finish off this max value by finding the y coordinate of the vertex. We're going to have a negative, then I'm going to have a 2 plus 1 and a 2 minus 5. I can see that that's going to give me a negative. It's going to be a 3 times a -3, which is a nice positive 9, which makes sense for the graph that we've sketched. So our extrema is going to be a max at 9. Okay, now this was supposed to all be review, and if any part of this was not review for you in terms of finding those intercepts or finding those vertexes, please come see me. The increasing, decreasing, and the inequality portion is probably new, but definitely you should be very, very comfortable sketching, getting a rough sketch, finding the vertex, and finding the intercepts.